So there's also another idea. It's called coterminal angles. And I have a picture of coterminal angles right down here. The coterminal angles are basically angles that kind of have a terminal side that looks the exact same. And if we didn't have this little directional arrow that we see opening up, then we would not know which one was which. So the first one's going to be our 150 degree angle, but then when we do a 510, we would have to actually do kind of a spiral action going all the way through. This is going to be 360. It's going to continue past 90 again, and then down to meet the same terminal side. So a co-terminal, co meaning two, terminal meaning the end. And actually think of it like the hands of a clock, and this is going to be our initial side, and you can just keep on spinning round and round and round, and you could just keep doing that. So think about it for just a minute. How did we come to 510? Well, we actually spun a full rotation around the clock one more time to get to that same location. So we did a 360, right? So that's actually what you need to do in order to find the coterminal angle in degrees. So two or more angles, they have the same terminal side. We're going to either add, and we can also subtract 360 degrees to get to negative angles. So once again, just take 30, and if we add 360, we will land in that same position, be at 390. And if we wanted to find a negative angle, then we could subtract and have 30 degrees, which I'm actually going to lead out with the 360, and do 360 minus 30, which is the same thing as 360. Subtract 30, but it's going to end up being the negative, so it would be at a negative 330 degrees. So you can go ahead and proceed with these and actually do some calculations and find the rest of these examples. So here we have another concept covered in this video. Not only the coterminal angles, where you add and subtract 360s to find 360 degrees to find other coterminal angles, but also something called a reference angle. So we have these quadrants, these angles, and reference angles are kind of like absolute value. So it's a positive acute angle formed by the x-axis and the terminal side of a given angle. And all reference angles, do remember this very important point, all reference angles are going to not exceed 90 degrees. So they're going to be between 0 and 90 degrees. So we can actually see all of these angles, these well, some of them are coterminal, like the 510 and 150 are coterminal angles. All these coterminal angles that we're talking about actually share something in common. It's called a reference angle. So let's actually locate it. And by definition, it's going to be the distance, the positive acute angle that exists, that's formed by the x-axis, so we'll go to the x-axis, and the terminal side. So that's actually going to be this opening right here. So it's going to be like the shortest distance. That's why it's always under 90 degrees. So in this case, I know that 180 subtract 150 is 30 degrees. Therefore, my reference angle would be actually 30 degrees. Now, this could actually be in any of the quadrants. If you think about it for just a minute, it could actually open down, up, and we could see that over here, up this way, and 30 degrees from that one, and 30 degrees from that way. So if we had an angle here, and opening this way. So with that being said, do you think maybe you can make some predictions? If we know these three, can you find another one that would share the same reference angle? Let's go ahead and give these a try. And I'll start with, let's try the 170. And maybe even the 200, negative 200 if you want to try with that one. But you kind of have this idea of subtracting from 180 in order to find your reference angle. Because we know that this is our initial array or initial side. And we know that 200 degrees. If we get our protractor out, we could be absolutely precise, but we know it's going to exceed and be ending in that area and open. Actually, normally it would open in that direction. However, it would, but we're not opening in that direction. So we want to actually start from our and go in reversed. And we'll go, let me grab my pen. There we go. And we're actually going to open up past the negative 90, negative 180, and go past that, and we'll end up somewhere in there, and we'll draw our other ray. So look out for that as you're drawing rays. I can do better than that. There we go. As you're drawing the rays and the positive and negative, watch out because you do end up in the wrong quadrant. However, finding the reference angle, it wouldn't have mattered really. And I'll show you why in just a moment, because they'll actually have the same one if we put it in positive or negative 200. So again, if we take 200 and we subtract 180 degrees, we get 20 degrees. And if you'll look, that reference angle will be located right here, that opening there, which I've kind of, it's a little off. Again, we'll play with some protractors and actually become more accurate. So this is 20 degrees is going to be the answer for our negative 200. So see if you can stop the video and try reference angles.